Holy fuck, a lot of... Hi, gamer. My channel is about watching me coding, working. I'm just going, right now I'm going over the git diff to do a commit, and then we can continue working. You always have to look at the diff before you do the commit. No firmware. Not even sure what that is. I think this is just an indentation difference actually. This whole part. It's a bit hard to check then. Just do a git diff W. Yeah, so this code is not good, and I'm not even sure. What do I want to keep this or not? I mean, I add some code and then commented it out, and it's new. Yes, I have Discord. It's all in the description below the video. Why do people never read that? I don't know what I want. Just leave it in for now. This is also not good. Maybe I should not do a commit. Yeah, maybe not. I don't think I want to add this even. I mean, I added the value of the second derivative to local extreme, but it turns out to be just wrong. Read the description, my username. If you scroll down below the video, you have the description of the video, and that contains a link to my Discord server. It's pretty much dead, but if you say something there, then I will read it eventually. Why would you want to DM me? Then you should join. See, I can invite people here. People you copy. Join that then. They have a math channel as well. I guess I have to store it somewhere because you have to also, if I jump back to the best minimum, then I just have to restore everything, including this fourth degree polynomial fit or whatever I'm using right now then. So it has something has to be stored in local extreme. But I don't want to store anymore just the second derivative in the extreme itself, but more, well, maybe, you know, two of them at left and right neighbor. Is that I'm gonna look what that is. The adjacent local extreme. So no, definitely not what it is, what I wanted. Let's have a look at So DLDW. So I don't know. It's the first. That is the first derivative. So what the heck with that name? Yeah, so yeah, I have to sort it in order to get it in this order, which is only debug code. So we don't know which one is left or right, unfortunately. Yeah, let's just pass them as symbols. So W0 was what? I think it's sample cons reference. What? No excess over the coefficients at all? Gotta be kidding me. Could use this. Man. Doing difficult stuff. I want to copy my general polynomial to a cubic polynomial. But everything I think of feels kind of dirty. Yeah, at the very least, I should be able to have an assert that checks that the degree's correct. Let's just add it here. Oh, I thought I kept it. Okay, now we even have the size equal to 3. And I think I'm just going to do a mem copy. I do always forget how that works. Destination source count in bytes, I guess. Of course. Destination. I'm not sure I have to do this or this. I think I should do actually this. Data on an array, so to return a pointer to the first element, right? Front back data, direct access to underlying contiguous storage. Returns a T pointer, so that's all we need. Now we copy from polynomial. Yeah, and then here with this, let's just go all out dirty. No, I need a pointer. Sorry, that's nonsense. I want to have a const pointer. Data. To get vector. Do I need to add a get vector on as well? Which of course should have been called get coefficients. I only make the const for this is, I don't know, let's have an, vector accessor. Accessors are usually not that bad. Yeah, now I have this accessor, I don't really need the max degree anymore. Just can get a vector and then call size on it. Let's delete that one. So we do auto reference, and you get the const reference because it's returning a const reference. Yeah, if I know the type, then I really don't like to use auto at all. Let's not be lazy and just copy the whole time. I'm gonna remove that get as well, why not? Wait, 3. The degree should be 3, but the size is 4. 1, 2, 3, 4 for a cubic. So instead of 4, I'll use the size of this thing. So at least we won't have an overflow now. Because we use the size of the target. But theoretically, this thing could be less. If the size is less than 4, it would be copying from God knows where. Hence the assert. Should never happen anyway. Copy is part of what? Well, it's like 99.99999% sure we already have that header. But if I literally use it here, I probably just should include a header that goes with it. My guess is C string. Yep, C string. Good, so now we can construct a cubic from a polynomial that was returned by the derivative. That is okay, the fourth degree polynomial here, which is just math polynomial, could have any degree. This is just a vector, size varies. When we calculate the derivative here, this returns a polynomial. So maybe I should not use auto here either. Let's give the type a name, polynomial. So we can create a cubic polynomial from this polynomial because I know that this is a fourth degree. And the function derivative subtracts 1 from the size. It creates a polynomial with coefficient size -1. So the size becomes was 5 and now it's 4. And then we copy stuff. So this thing does have a size of 4. So it has 4 coefficients. We are sure of that. So the assert will never fail. The assert in this constructor. And I'm just going to pass the derivative of the cubic derivative, which is then the second derivative, because a cubic polynomial has a derivative function, I say, without knowing that for sure, but I'm looking, still looking. Yes, here, derivative, which is, no, it doesn't. You can evaluate it. Now let's add one then. Quadratic polynomial has 3 coefficients, and well, we can just construct it from the actual thing. So the first one is the constant penalty. To return and then pass the that thing is not explicit, is it? No, it's not explicit, so we can just use the braces here. And then pass the 3 coefficients of that thing, which is going to be, I think this is the constant. And then we have that as the one that has to be multiplied with x once. And this is the coefficient that has to be multiplied with x squared. So the quadratic polynomial is a wrapper around an array of size 3, 3 doubles, plus we use it only here at the moment. So I might as well construct it in place in the argument. So I'm going to do this not as a const reference, although I don't think it matters. If you use a const reference and everything is inlined here, because I'm going to inline it, and the compiler will also see that the const reference isn't really needed. So it's not going to use a reference then. But yeah, well, I don't know. So this is the second derivative of my fourth degree polynomial. Second derivative, we'll just call it second derivative, because it really has to be it. Maybe a comment. Second derivative of the current fourth degree polynomial. So usually I just add where that is being called from. So this is being called from handle local extreme. And now I did a jump to the start of the function, and it's super stupid. You can't jump back. It doesn't even say where it came from. I can do undo redo, but I don't know about this jump. Anyway, this should really only be the only place where we call this from. It's too specific. And the idea is now that I'm going to store in local extreme two values. One for the leftmost and one for the rightmost. So let's just store that in an array. Double 2. Missing header. Now, hopefully this one doesn't include the other ones, but that seems very unlikely. No, it doesn't. We're not in namespace math here. Oh, that said second row. Yeah, no, of course not. Math. Well, I can imagine that maybe we did not include quadratic polynomial here. Extreme type. Just included. Quadratic polynomial dot h not found. Quadratic polynomial dot h in tests. I think we are in yeah, this is not nice, but eventually I'm going to move stuff around and then those dot dots should disappear. Cannot assign the return value because operator blah returns a const value. Oh, okay. I should make it mutable then, I suppose. Either that or remove the const. Theoretically, just should remove the const, of course, but I think that will cause an avalanche of having to remove consts, which I wouldn't like much. Actually, it doesn't. Or maybe it does after we fix this bug. Index 1, yeah, duh. 1 minus index 0. Okay, that's what I was hoping for, because I had no idea what else I had to change. So I removed this one, so we have to make changes now here, or you use the new code. Yeah. Hey, little jab. Happy coding. Or you're not going to code yourself? Determine the ratio between the derivative predicted by the fourth degree polynomial fit and the cubic fit. Okay. Let's see. Homework. Make it good. Okay, so this is the local extreme that we're talking about. Oh shit. Yeah, if we go to the left, and the use cubic is the one on the right, so we are, this last found local extreme is here. We are going to the left. Then we have a new measure point here, which splits up an existing cubic, and then we have the cubic on the left and the cubic on the right of that. And if the cubic that we used is on the right, then it might be adjacent to the local extreme. That is, the local extreme fitted a fourth degree polynomial through 3 points. 1, 2, 3 points, and that's the local extreme here. And then the point on the left of it, that is the edge node of the local extreme in the left direction. If that is equal to the use cubic next node, which means that the use cubic is always the left node of 2 points. So if we use this cubic, then the use cubic points to this point, and next node is then the one on the right. If that one is the same as the edge node of the local extreme, then this cubic that we are using, apparently want to use, is connected to the points that we have the fourth degree fit of. So in that case, that's true. And then on the right side, or on the left side, or no, I was talking on the left side, the right side, same thing, but then mirrored, and in that case it is just the use cubic, because that is already the left point of the cubic. And if that then is true, then we have to calculate the second derivative ratio between the use cubic second derivative at that point, so not this point. But at the returned edge. And as well the second derivative at that point. Which I don't know, I already have. I don't think so. Get second derivative. H direction. So that's kind of the border of this function then. This returns the node, and this returns the second derivative value in that node. Thinking about it, maybe just storing the the cubic polynomial itself, and then calculate the second derivative right here. So instead of having this, then I just ask for the second derivative. No. I would ask for the cubic polynomial here. And then evaluate it at the same point. I don't know. Let's leave it like this. Yeah. So we need to store. I need to have two arrays then. One that stores a sample node const iterator, and the other one needs to store a double for the second derivative value. And I did already store the latter, I think, which is stored in local extreme. So maybe the thing already has a name and I just forgot it. I added second derivatives. Second derivative is can't type. Yeah, I just made a setter, not a getter. How the hell did I call that thing? Which one's the direction to int? So that should return, I put it the left one at 0, so this should make sure that it does it do what I want. No, it doesn't. It just returns -1 and 1. I have to call s index, and then the -1 turns into 0. I don't want to say much, but is that divided by 2? Yeah, I think so. It has to be, otherwise I would have crashed 100-fold over. I'm using this already. As index, okay. Bleep. Brop. Get second derivative. Get second derivative, okay. Still need a get edge node one then. And that returns a sample node const iterator. Yeah, well then let's not pass a sample. We just pass those iterators. Hopefully I have that. Not even sure. To that thing now must pass considerators. These are the references of usable samples. Absolutely nobody knows why W1 is using I0 and the other way around. But that's what they are. Usable samples is storing. Drum roll. Sample node considerators. Yay. So then that's what we have to pass instead of this. And that was I1 then. And I0. Yep. Hmm. I guess there's a good reason that these are still undefined. Ship it. Yes, okay, well done. Let's not ship it, but continue running it. Continue running the test suite. I just should do what this guy said. Run. No. Bleep. Plop. Boing. That one is found. Now we go there. And we crash already. Search current equals left off or current equals right off failed. Really? It must be left of 4. I think this is 4 here. Left of 4. And right of 0. And current is in between. And that should never happen. Well, I don't know. I guess this assert tells me that there is a bug, even though I don't understand it at the moment. Should have to do something with what I just coded. There's only one cubic and we don't want to use it. Dubious. Inserting 4 and then after that we insert 5. See, this is all a high irregular. I think that what that means is that 4 is, you can even see that I think, on the left of this maximum. So the cubic between 5 and 4 does not include the maximum. Clearly, nor does the cubic between 0 and 5. It does just going up, 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 up. So why would we ever prop 5 after 4? Obviously, we should have jumped to the maximum of the cubic from 0 to 4. Which means that at the moment we got 4 here. That cubic is initialized. It's going up. Choosing maximum of left cubic because the right one does not exist. And that cubic should have been used, but it says not using it. Because it's second derivative at 4. Okay, that's bullshit. Four B. I mean, come on, 4. What is the last extreme here? I'm pretty sure that 4 is not part of the last extreme. Which is 2. Just in case, let's have a look at what this fourth degree polynomial is using. Yeah, see, nothing. It is using 4 didn't even exist at that point. We have 0, 1, 2, and 3, and it is using the sample at 4, which is this one, 3.6, this one, and 3.8, 15, this one. Oh, okay, so it's using 0, 1, and 3. Is down here. So we have fitted the cubic polynomial through 0, 3, and 1. And now we're rejecting the cubic between... Oh, we are rejecting the cubic between 0 and 4. That does have 0 in common. So it could have been rejected based on the fact that the second derivative in 0 is way off in comparison to... I don't believe that though. I mean, obviously that's just going to be this slope. Oh wait, slope is a slope. But I mean, it's kind of a straight line. Yeah, you never know. Maybe it's... Maybe it is more than a factor of 2 of the curvature. Second degree. Choosing the given because the second derivative at 4. Yeah, the 0 is in 4. It's coordinate 4. And now I lost my drawing. Great. So you can see the fourth degree polynomial. It's this green thing. which is going through 0. And that should have a pretty small second derivative in 0, I think. No idea what is considered small here, but second derivative at 0 and 1 are 10,000. I don't know, feels a bit much. Let's verify that. Already passed that thing. So I have a second derivative in 4. It's not even mentioning 4 here. Okay. That doesn't matter. You can just ask it. What is the value of the second derivative in 4? It's not a maximum. Minus 53, that's complete bullshit. Complete bullshit. Okay, is that correct? Yeah, with the first derivative here, this one was correct. So that's going to be something like 2 times that, so minus 6.86 times 10 to the power 6 plus 6 times 6, something 36 times 10 to the power 5. A minute, it's, I can't, 2 times 3 times 6 is 36. The rest can be ignored. So 3.6 times 10 to the power 6. 3.6 times 10 to the power 6 minus can't do that from my head. Minus 4 times 3 times 3, 9, 4, 3, 5.1. Looks like scroll down, yeah, that's it. So it does have the correct thing here. And then I asked it to fill in 4. I'm just going to multiply this with 16. and then subtract 6.8632 exponent 6, and then plus 4 times 3.611352 exponent 6 is 10,608. Or 10,686, 96. So it's again 10 off, but okay. And then you ask an artificial intelligence, and it comes with minus 53,000 random number. What a waste of money. Well, I'm not paying anymore for ChatGPT. What I was referring to, building the thing is a waste of money. I have only one word for this. Pathetic. Anyway, this value was correct. This surprises me pretty much, but okay. And then again. So apparently the second degree value of this cubic here in 0 is 2572. That's cubic between 0 and 4. 4 is not printed yet. Oh, I have it here. That's also funny. I think I made a mistake. It was correct, or... And then it says, you're absolutely right, I apologize. Well, it should have said, no. I did it right. It's just the same thing. Okay, never mind. $3,913. So that's close enough. And the other one, 2,573. Also close enough. Hello, Ola Soydora. Thank you for the compliment. Well, if you mean with the recognition, the number of viewers, well, it's kind of tough to sit through my slow mumbling. If you mean that I don't get the recognition I deserve in terms of payment, then I agree. I'm not being paid for this. Not related to my live streaming, but yeah, I think job hunters are not working hard enough, considering the stuff I have on GitHub. I've received maybe, I don't know, a handful of job offers. Like 5 or 6 at most during my life, based on random people finding me through GitHub, basically a code that I put online. But I don't care because I turned them all down. Okay, so apparently my heuristics of comparing or calculating the ratio of the second derivative is nonsense. Because yeah, I don't get paid for this, and I don't have a job. And don't ask me where I get my money from. I would take a job. I think I would take a job if it is interesting enough, but the demands I have are always so much higher than people are willing to. I mean, if always, I mean that handful, for example, people send me a job offer and I just turn them down because I'm not interested. Not because of the topic, but stuff like I have to come to this United States and stuff like that. So I'm more like, yeah, well, why can't I work from the Netherlands? Actually, the last one was one where I did not have to move. Thought it was chess.com. Not sure anymore though. It was involved with chess. Someone just found my chess thingy that I wrote, God knows how long ago. They had a team that would, was going to try to make an artificial intelligence-ish thingy, I guess, that would not just say what is the best move, but explain why it would be the best move. That was interesting, because that's definitely missing. If you analyze a chess game with the computer, then you don't learn anything. It just says, oh, this move is wrong. +7. And then in many cases, nobody has any clue. So it would be, why that is the case. It would be so nice to have an artificial intelligence trained on chess in a way that it can say, this is a bad move. Because it allows black to get the pawn majority on the queen side, or it gets an advantage in development. You know, something that actually explains the thoughts of a grandmaster when they look at that position. But then I said something. I didn't really want a job, I think. But then that's why I said, okay, I'll do it. But then I want to be the team leader that makes all the decisions. So basically, then it becomes my project, and the rest of the team will do what I want. And when he got back to me, that guy was still thinking about it, I think. But he said, yeah, the rest of the team doesn't like that idea. So I had to turn me down. I had not expected anything else, I must say. But hey, if he would have said, okay, you know, we're gonna do it your way. Okay. Maybe I would have had fun with that project then. Well, that's the thing about what's wrong with the rejection here. It's definitely wrong. Let's go one step back. But look at this cubic. This cubic just lays on top of this function, yeah? All the way till 4, it is a almost perfect match. And even below 0, it's a pixel precise match until maybe 300 minus 300. Then I see it deviate a bit. And the fourth degree one, yeah, it's hard to see because this cubic is on top of it as well. But it's damn close, really. I mean, it's in if you squint your eyes or something, then it's the fourth degree is just on top of it, right? All the way up till here-ish. So both are on top of the same function, therefore they are on top of each other, even though I'm not drawing them at the same time now. And then I say, it deviates too much because the second derivative isn't equal. But the second derivative, I would say it's just not, there's no bending here at all. It's basically a straight line. And the only thing that should count here is the fact that the derivative is the same. And that is, per definition, the same because that's how these things are being fit. I would say that this cubic, so try to remember this fourth degree fit here, which lays on top of the thing around 0, totally, all this way. Matches perfectly with this cubic, around 0. Just matches perfectly. Let's make this a factor of 10 for the time being to see what happens then. What? Okay, that doesn't look good. Even the indentation is different. What is this doing here? What are they doing here? Why did that even compile then? Oh, it didn't have a brace, I mean. Not rejected now, and see, we find immediately the maximum. Is this one rejected? Now, also this one is not rejected. But. See, now here there's a clear difference. The curvature of this thing here, which is equal to the curvature of the fourth degree fit, is totally different from the curvature of this thing. Totally. Yet it is not rejected. Second derivative at 3 and 0. Oh. 4 is not there. 4 is not there. What? Why is 4 not there? Oh, well, I'm taking the wrong one then. Okay, that should have been it's kind of nonsense to install this one then. But okay. Doesn't matter much, I suppose. But this one should have been 4, not 0. It's wrong, but easier to copy paste. No, maybe not. Choosing the minimum of the left cubic with the right one does not exist, aka left of 5, aka this cubic. The only cubic that we have. Not using the cubic, however, because its second derivative, which is minus 1589 at 4.22, which is at 0, 0.4, I mean. It's more than a factor of 10 different from that of the fourth degree polynomial in the last local extreme. It prints 0, which is the last local extreme, but of course I would have liked to see a 4 here. The label of the actual thing. Hello, Panda. Yes. I have no idea. You should not ask me that. Second derivative at 4 is more than a factor 10, different from that of the fourth degree polynomial in the last local extreme. Okay, it kind of describes it. No arrow though, where we do jump to then. Slightly annoying. Why would I not have an arrow here? It does say next probe. Oh, because I don't have a cubic, so I don't have a y value. I wouldn't know where to put the arrow. Oh. So we jumped to 6 here. And the next jump is there, because it does use the cubic. This cubic can no longer be rejected because, wait a minute. This is a cubic through 4 and 6, I think. That could still be rejected, couldn't it? This is the minimum of the left cubic, left of 6, because that cubic, 4, yes, it's closer to the last extreme than the right cubic. Yeah. And why is it not rejected? Maybe if it is not rejected, I should print it. The derivative stuff as well, if it made the comparison. Let's put it that way, because sometimes it won't. Yeah, let's do that. So if this is considered and it was set, which means that this is true, then I should print it. If we get here, I suppose. Now that's what I mean, close. Oops. Wow, unknown. Hmm. Yeah, well, by the way, so we found this one now, and then, well, it couldn't fit a fourth degree polynomial, so I just randomly picked 8 here. And now we have a fourth degree polynomial, this one. And it wants to jump here, which happens to be on the right of the last point, 8. A tiny, tiny, tiny little bit. It did set a range because this cubic here does have a minimum. Sorry, a maximum. So there must between fat quotes a maximum between these two. I would say, well, no, it doesn't. The thing could have go like this. But at the very least, it's not unlikely that there is a maximum, and if there is not a maximum, then there's no harm in trying. In which case we just wouldn't find it, and then we would get past 5. Find the maximum over there. But the fourth degree polynomial fit overrules because it is within the range. I mean, we know there is no maximum between 7 and 8. But we don't know if 8 is not, just here, and then immediately after it goes sharp down. Hey, it actually does. So it is better to jump here than to jump to this maximum, in which case we would maybe find that maximum and miss this one. So you can't blame the algorithm to want to jump to this point, I think. And beautiful. Now that's 2 points, super close to this local extremity. Bleep. And the fourth degree gives us the other one as well. Wow. How beautiful is that? However, this one is clearly higher than that one. So now we give up. We give up going to this maximum and then finding that minimum, which in this case is not that bad. But why would this little wiggle stop us from exploring this beautiful, maybe lower minimum? I mean, dang, that's a real global one within what I see. I think we stopped too early, but algorithm is algorithm. We found the local. We found an adjacent local extreme, which is higher than that one. Therefore, we abort this direction. And I'm gonna go with my algorithm. So until it works, anyway. So we're going to jump back to this point now and then stop completely because that one was already found. Yep. Bleep. The end. But a bit random because I just picked some other number, 10, which happened to be correct or made this work. Surely we can find something that I probably should remember this. I see it though. I'm not done with that yet. Gabrielle said, I think Gabriel was talking to himself probably about his own program. Cannot really follow it. Okay. Let's run this different function. Still we can't get rest. Can't get dinner. Only call this function if trying to get a local extreme. Well, there is no local extreme. Apparently. Now, why would I do that? Okay. Apparently we can get there without having a local extreme. No, that doesn't make any sense. Last extreme cubic is set, then it must have a local extreme. I think we just said it. Hmm. 6 is the new, looks like the new local extreme. There's minimum here. Oh, so it's being set, and then we have to divide the last extreme cubic before we can continue. So that's why we don't have a local extreme yet, even though this one is set. I suppose, well, I don't know. Maybe I should just pretend that. What to do in this case? Pretty sure I should just set the thing to 0, to false. This. Either that or not set last extreme cubic yet already. Harder. Using it using last extreme cubic. The feeling that it's the only place where I use it. So I might as well use the other class member, cubic used. I just want to change all of them. Should have done that immediately. Oops. I want to repeat the same test as before, which means that before I compiled, this one failed, and that failed because this seed. Yeah, seems to have worked. If I show this, then why do I not jump somewhere here? 5.5. between 3 and 8. Totally 5.5. Working on the edge now. What? Not sure what happened there. I think we went over the energy or something. We find this minimum and then we should find this maximum. Go up. Okay, that's kind of strange. That's not nice at all. And yeah, we stopped because we were over the energy. No. That one is found. This one is found, and then we stop. Okay, that makes sense, but did not find this maximum at all. Completely jumped over it. So that must have been another case of rejecting a cubic for the wrong reasons. Let's try that again. Let's see. No, maybe not. I agree with this one. It should be on the right of that point, and that is. And we jump to the maximum of this thing. So we jump somewhere here. Yeah. And then it correctly says the maximum must be in between here. It should be using this cubic, no? Not using this cubic. Okay, that's a problem here. That's definitely a problem. The second derivative at 3. Yeah, see, there's another case of something I would consider a straight line that isn't straight enough. I mean, come on. It isn't even more than a factor of 10 off. It just curves the other way. Which I think should be okay for a straight line. Tiny little bit go one way or the other, doesn't matter. I think I should convert the second derivative somehow to the curvature radius and then compare the radius to the scale as well. So in this case we have an almost straight line, which means that the radius of the circle that touches this curvature is very large and therefore much larger than the scale and therefore not interesting. Not interesting to calculate a ratio. Or maybe I should just divide it by the scale and then we have something much larger than 1, therefore do something with it, which then compares equal anyway. If both two things are much larger than 1. Something like that. Something, I don't know. Slightly more magical heuristic. However, my scale is purely horizontal and a radius of such a touching circle would be there, pointing any direction. So that only has any meaning if I would use the same what is it called, density scale probably for x and y. So in this case we would have to blow up the vertical size close to more than a factor of 100. Still realistic to compare the radius of the circle then with the horizontal scale. See what a difference indeed. Here we have like a circle that has a radius of near infinity, while at this point it would be a circle like this, like really tiny circle. Yeah, we definitely have to do something with that radius. It's still reasonable radius, and yeah, it's already super big. Like way larger than I have to think about that. Yeah, let's make up something. In the meantime, I'm going to eat and stuff, so I'll be back later. Oh, I feel like playing chess. Oh no. It's time to eat, so instead I'm going to play a game of chess. Bing, boing, ledges. What is this actually? Okay, study of reflex epilepsy induced by playing chess. Whoa. There's actually people that get an epilepsy attack when they think about chess, or play chess, or anything with chess. I'm starting to get bored. This guy's... the progress is so slow. He's not really saying anything. Or at least... taking way too much words. It's the third time that he is repeating this. Start to just read a bit more diagonal here because the content is toch empty anyway. No, that was a waste of time. A bit inaccurate. Should have put pressure on that one. Good take here, exchange queens. +2. Oh, motherfucker. Why? Why am I doing stuff like that? Now I'm down 1 pawn. Mate. This is mate. This is also mate. No, I can go there. So that this is mate. Yeah. Giving away the queen. Ugh. Stupidity. Nou ja, I'm gonna go eat.